Hey everybody, so we've answered a lot of questions in our meeting, so I won't make this a long video, and I also uploaded just a photograph if you just want to look at the answers and the work. But I did want to point out a couple of things. First of all, be careful to watch these. Here we're doing a square root, so you definitely want to take out, like every time you have a pair, you're going to take something out. So my x to the 7th means that I have 3 pairs, but then 1 left over. But then on some of the other ones we have a cubed root, so make sure you're taking out a full set of 3. So there were 4 sets of 3 with 2 left over. I'll also take a minute and point out in our square roots that if they specifically say negative, that means the answer is negative. If they don't, then you technically have to write both. We don't really mess with that with variables, although the book often gets technical and writes the absolute value to show that there could have been a positive and negative, but I don't require that of you. I'll also point out that I squared is equal to -1, so on all these problems where we're working these out, every time I simplified, in case you got confused, everywhere there was an I squared, that turns into a -1. So on these we're adding and subtracting. Sorry, there's no I squareds. But here, for example, my 16I squared turned into a -16. And then I would remind you down here, I think this is probably the trickiest one of this little bunch. Down here, because I'm taking a cube root, and because when I rationalize what I want is a whole number, that's my goal, then I need to multiply by whatever it takes to make this cubed root into a perfect cube. So I didn't multiply it by cubed root of 9, I multiplied it by cubed root of 3. So that when I finished, I would get cubed root of 27, which gives me a whole number. So that's your goal when you're doing these. For square roots, it's pretty obvious because you can just multiply it by itself and then it will be a perfect square. It takes a little bit more creativity with a cubed root or a 4th root because you want to make something that makes a perfect cube. And then everything else, the rationalizing we talked about in our meat, but you're just going to multiply by that conjugate. And then even though that leaves you something really ugly on top, then we've still done it correctly. All right, let me know if you still have questions about this section, and look for Chapter 8 coming soon.